This topic is related to experiments. Yeah.
Yes, sir.
So we have here, look, at the beginning, you see it's written 2.1 measurements. Then there we mentioned 2.2 errors and uncertainties. Then we wrote here, mm, uh, this way we continued from the learning outcomes of Cambridge syllabus. The syllabus you have to follow. Look, all these things are included from the learning outcomes of your syllabus.
Yes,
And
sir.
also, I tried to give some of the examples, related examples, which can be useful for you from past paper. Some examples I gave you here related to the theory. Related to the theory, so that when you will go to solve the worksheet, you will find it a little bit easier.
Yes, sir.
That's why I tried to arrange the notes accordingly. Here we have 10 pages. These were actually written by pencil. That's why the scanning is not that much good. So you have to read it carefully and write the
Okay,
notes.
sir.
Can you read please from 2.1 measurements?
Measure lengths, rulers, micrometers, calipers, measuring tape, weight, mass, using a Newton meter, balance, angle, protractor, time, clocks, stopwatches, time base of CRO, temperature, thermometer, current voltage, ammeter, voltmeter, ohm meter, multimeter, calibration curve for current temperature.
Yeah, we are having here all the quantities we normally measure in the lab, physics lab, right? Those are
Yes,
mentioned
sir.
here. And beside that, the instruments name, which are used to measure these quantities, uh, those are also mentioned here, right? And these are also followed from learning outcomes of your Cambridge syllabus. And you see here
Yes, sir.
with current voltage, we also have resistance. This one you missed.
Yes,
So
sir.
you write this one. You already wrote the topic name, right?
I so I'm writing.
Yeah. Write topic name, today's date on your physics copy. Okay, physics record copy. Okay.
Oh, sir, sir, I have to bring a pen.
Yeah, yeah. Please.
Yes, sir.
Yeah. So please write the topic name. Topic two, measurement techniques. Then write 2.1 measurements. Uh, then you
Yes,
write
sir.
measure lengths. You give hyphen. The way I gave, same way you gave. For measuring lengths, we are using the instruments, rulers. Then we are using calipers, measuring tape, micrometers, right?
Yes,
Isn't
sir.
it? For using for measuring like the lengths of 0.1 centimeter accuracy, we can use ruler or measuring tape, right?
Yes, sir.
If the length is more than 100 centimeter, that time we must have to use measuring tape, isn't
Yes,
it?
sir.
Like the simply we can understand. You also got it in your O level, right?
Yes, sir.
Yeah, so we are not going for details here. Like the length
Sir,
of
should
your,
I copy? Yeah,
yeah,
sir.
yeah, yeah.
So everything under measurement.
Yes, 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 yes. You have to. You have to. You have to write these notes. This is your, resource from where sometimes you have to that, uh, check out and pick this information to solve your problems. These are very much
Yes, sir.
necessary for you. Okay. Though these are very simple thing, you know it, but the things coming after, those are new for you. So write it quickly. Yeah.
Yes, sir.
Weight, mass, we can use Newton meter, balance to measure, then angle, protractor, quickly. Yeah. The time,
Yes, sir.
clocks, stopwatches, time base of CRO. So clocks, stopwatches, before. Now you also know
Yes, sir.
time base of CRO,
So,
how to use
yes, sir.
time base of cathode ray oscilloscope. CRO means cathode ray oscilloscope, right?
Yes, sir. We learned that. mm,
Yeah, that one also you learned, in O level.
Yes, sir. Yes, sir.
Okay, now temperature. We are using thermometer to measure. Then current, voltage, resistance. We use ammeter, voltmeter, ohmmeter, and multimeter, right?
Yes,
Then
sir.
calibration curve. Are you writing?
Yes, I'm writing.
Yeah. Till where you wrote?
Thermometer.
Okay, okay, right, right. First, calibration curve. I will explain you now.
Okay.
Calibration curve means to to know one unknown things from some known things, right? If you
Yes, sir.
know some of the information, then using those information you can use your technique to find the unknown things. Like this graph. This graph we gave one example. We have here current and voltage values. Can you draw this diagram, please?
Yes, sir. I'm drawing.
Yeah, yeah. So look here, for 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, we are having the current only for 2 volt, right? 2 volt, the current is 0.2 ampere, 0.2 ampere. For 4 volt, the current is 0.4 amperes, right? Isn't it? Now,
Sir, why is 0. Acha, sir, no, no. It's okay.
so if someone is asking you now, what will be your current at 6 volt, then you can find it, right?
There's 6. Yes, sir.
Okay, so at 6 volt, what will be the current?
0 0.6 ampere.
0.6 ampere. That's very easy, right? Now you
Yes, sir.
write also this question: what is the current at 2.5 volt?
So 0.2, 2. So it will be 0.25.
0.
No, wait.
0.25, right?
5. Yes, sir.
0.25. So it can be this is one example where you are finding some difficulties, little bit difficulties. They can ask you also what is the current at 0.95 volt, right? This way they can ask you,
Yes,
and
sir.
here you are getting very simple values. You can calculate easily, but there are some places where it is much more difficult, right? Also,
Yes,
you
sir.
know about Hooke's law. where we get extension load graph, right? Then if you are given one graph for some known values, known loads, the extension are there. Then for one unknown load, you can find the extension using that graph, isn't it?
Yes, sir.
And also we can find the original length. We can find the new length from that graph, isn't it? Using formula. Okay, now when we are doing experiments or we are taking readings, we are finding some errors and uncertainties, right?
Yes, sir.
Where uh, if we ignore them, then our result coming is not appropriate for our calculations or for making charts or getting the values and using in our other steps of the experiments, right? So we
Yes,
try
sir.
to make the readings as much as possible more accurate. Okay, for that one we have
Yes.
to find the sources of these errors, and we have to take steps so that those errors can be minimized as much as possible. Okay, so
Yes, sir.
this type of errors are mainly of two types. One is systematic errors, another one is random errors. Okay, one is systematic error,
Systematic error.
yeah, another one is called random errors. So what is called just systematic error? Systematic error is mainly coming from the instrument error. Okay,
Yes, sir.
uh, and systematic error also comes from the person, if the person is taking the reading always in the same position, the incorrect values, that is also systematic error, because of his wrong way to take the reading is coming always the same way wrong. Okay, that one is also
Yes,
systematic
sir.
errors. So systematic errors definition is given there. Please write it. Write 2.2 errors and uncertainties. Then you write systematic errors.
Okay, sir.
Here you see I wrote some numbers 3, 5, 6, 7, 8, 12, 15, 17, 22, 25, 26. So these numbers are related to the questions MCQs which are on the basis of errors and uncertainties. Is it clear?
Yes, sir.
So I tried to identify them so that students can get them easily. Huh? MCQ 3, 5, 6, 7, 8, 12, 15, 17, 22, 25, 26. These are on errors and uncertainties. So if you understand these definitions and the examples coming, then you can answer these questions easily. Okay, are you writing?
Yes, sir.
Can you understand it? The my writing you understand?
Yeah, I can, sir.
Yeah, systematic error is consistent, repeatable, error associated with faulty equipment or a flawed experiment design. So in two ways it comes. One is faulty equipment, another one is flaw in experimental design. And we gave here sources, sources of systematic
So
errors.
should I write the sources?
Yes, yes, you should write each and every word, because this will come, you will understand, otherwise you'll forget, you cannot apply your ideas. I did not give you anything extra. If you write, then it will be only 4 5 pages maximum. My I wrote only A4 paper, half of, that's why it came 10 pages. You are writing the full page, right?
Yes, sir.
That's why it will come only 4 5 pages. So this one, zero error. Zero error, you understand, right? A scale that does
Yes, sir.
not read zero when nothing is on it. Like when you are measuring the length, maybe the ruler you are using is not starting from zero. Okay, it can be, from there might be some length before zero, huh? In your ruler.
Yes, sir.
Those are called dead space. Hmm? What is what is that called? Dead space.
Dead space.
Yeah. So those reading you have to minus. Like if you are having here, your length, this anything you are measuring with this ruler, you are getting, for example, 5.2 centimeter. Okay, you are getting how much?
5.2.
5.2 centimeter you are getting, but the dead space is they are another 0.2 centimeter. How much?
0.2 centimeter.
0.2 centimeter. So that time, what you have to do?
Sir, I should minus 0.2.
You should minus, or you should, what you have to do? Plus. Here you have to plus, isn't it?
Oh,
Because the reading should be actually 5.4, but you are getting 5.2 in the ruler, isn't it? Because that space, dead space is not counted in your ruler, isn't it? But the length of the object is extra, that part, 0.2 centimeter extra. So you have to add there. You have to measure dead space's length, then add this 0.2 centimeter with your reading you are getting on the meter rule or any scale. Is it clear?
yes, sir.
Okay, so this is one thing. And if you are getting your ruler is starting from actually 0.2, it is starting from 0.2, not starting from 0. Then you are getting the reading 5.6. How much you are getting?
5.6.
So that time you have to subtract,
Sir, can
because
you scroll down a bit?
yeah, I can. That time you have to subtract. So you understand it, what I said
Yes,
about
sir.
zero error. And this zero
Yes,
error
sir.
can be in the ruler, it can be in the micrometer, it can be on any of the instruments, right? Even it can be in
Yes, sir.
ammeter, voltmeter over there. So you have to check out your instrument. Is it giving any zero error? Then you write the value and add or subtract it accordingly. Okay. Now this
Yes,
one, did you understand that systematic error? Second example, a person consistently takes an incorrect measurement For example, they might think the 3 centimeter mark on a ruler is the 2 centimeter mark. This is happening due to the parallax error. Okay, so beside this one, you can give one hyphen, then you give parallax error in bracket. You write parallax error. This is one of the example where a person is always taking the reading from that position and always getting the same wrong answer. Is it clear?
Yes, sir. Sir, can you read the last line?
Which one? Person.
Uh,
This one.
the random errors are in.
Okay, I'm reading. Look,
Oh, sir, sir, inconsistent. I
are
understood.
inconsistent and occur in both the directions. Do you understand in both the directions? What is called both the
Yes, sir.
directions? Huh?
Yes,
Like you are measuring the time by using stopwatches, right? So
yes, sir.
your exact value for 20 oscillations, it should be 10.5 seconds, right? Isn't it?
Yes, sir.
But in some of the readings you are getting 10.8, some of the readings you are getting 10.2 or 10.3, right? Or
Yes, sir.
9.8. So in both direction, that means you can get more or you can get less from the real value or the standard value
Yes, sir.
in both direction. That means then, for example, time for 20 oscillations of a simple pendulum. So you are done with random errors, right? So during
Sir,
random, yeah, tell
no,
me
sir, nothing.
anything.
No, sir, I'm
Okay,
done. Right?
okay. Random errors you can minimize by taking the average.
Yes, sir.
Okay, it's written here, right? Is it written that how can you remove random errors or minimize random errors?
S- Sir,
It's
we
not written.
didn't. Mm, mm, no, sir.
So you can write it that random errors can be minimized by taking average. Huh? By taking the
Sir,
average.
minimized by.
Taking average of the readings or mean of the
Sir.
readings. Now here we have one nice thing, that is accuracy and precision. Though they both are sounding the same, but there is a little bit difference. Accuracy and precision. First, you try to understand what is called accuracy. Can you read from accuracy here?
Accuracy refers to the closeness of a measured value to a standard or known value. Example, if in a lab you obtain a weight measurement of 3.2 kg for a given substance, but the actual known weight is 10 kg, then your measurement is not accurate.
Yeah, yeah.
Precision refers to the closeness of two or more measurements to each other. Example, if you weigh a given substance uh, 5 times and get 3.2 kg each time, then your measurement is very precise, though it's not accurate.
So you are measuring 5 times, 6 times, 2 times, 3 times. You are getting the same value. Those are precise, right? Those
Yes,
are precise. They are close to each other, but they are not accurate. Hmm? Accurate value is 10 kg, but you are always getting 3.2 kg. or close to 3.2 kg. So your reading is coming precise but not accurate. Is it clear?
Okay, sir.
So you wrote
Yes,
it
sir.
accuracy.
Okay, sir.
So are you done with topic one completely? Is there any still any problems? Navid? Hello, Navid. Navid. Hello, Navid. 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 Hello, Navid.
Hello,
Yes.
sir.
Yes, your microphone is working now. Hello.
Hi. Oh, sir.
Yes, yes. Yes. Are you done with accuracy?
Sir, I'm writing. I'm right.
Yeah, right, right.
Sir, almost done.
Yeah, please write.
Sir, I'm done with accuracy.
So precision, you write. Done.
No, sir. Sir, done.
And here we got that precision is independent of accuracy. You can be very precise but inaccurate, as described above. You can also be accurate but imprecise. Hmm. Okay.
Yes, sir.
So
Sir, should I copy?
yes, yes, please copy it, please. So are you done with this
Yes, sir.
real life example? Huh?
Yeah.
You are done with the first part, right?
So I'm doing.
If the player shoots with accuracy, his aim will always take the ball close to or into the basket.
Sir, done.
Yeah, then if the player shoots with precision, his aim will always take the ball to the same location, which may or may not be closer to the basket. So the third point, a good player will be both accurate and precise, but shooting the ball the same way each time and each time making it in the basket. So you want to be a good player,
Yes,
Navid?
sir.
You should
Yes,
be
sir.
both accurate and precise. Okay,
Yes, sir.
join your class on time
Yes, sir.
and do the given work. Okay, do the given work. Always be on your toes, right?
Yes, sir. Sir, done.
Okay, very good. Now the is the nice thing you say uncertainty. Huh? So uncertainty is very new to you, right?
Yes,
Uh,
sir.
if uh, if we are taking everything nicely, we try to take the measurements in a way there is uh, you know very less very less systematic error, very less random error. Even after that, we have some errors, right, in our reading. We have some doubts,
Yes, sir.
and this doubt or these errors will have a range. That there might be possibility to have errors within this range. Like when we were doing in topic one, the skill diagram. Can you remember that we tried to take the measurements or the calculations, everything accurately. However, sometimes it happens little bit difference, right? Yeah?
Yes, sir.
To get the answer from the standard value, it is little bit different. So that one we are giving with a range plus minus, right? Maybe
Yes,
uh,
sir.
standard value is 6.6 Newton, but some students will get it 6.4, some students might get 6.5, 6.7 or 8. So we are giving a range. So this range is known as uncertainty, right? This range is known
Yes,
as
sir.
uncertainty. So here you go, uncertainty. Can you read here, please? Uncertainty.
The total range of values within which the measurement is likely to lie is known as its uncertainty. Sources. Even if there is no error in the measurement, there is always some doubts or uncertainty to its value. It is important to understand that when writing down measurement, the number, can you scroll down?
Yeah, yeah, sure. Yeah. So
The
please write
number
it.
of
Are you
okay,
done
sir.
with writing this part? Sources, till sources.
No, sir.
So you write it. First you write till here sources. Then we will continue there. Already you understood what is called uncertainty, right? From my explanation and the
Yes, sir.
example I gave. So now you'll understand everything. And look here, beside this note here, I wrote some numbers. 1, 2, 10, 11, 16, 18, 19, 21, 23, 24, 27, 28. These are related to uncertainty. Okay?
MCQ, sir.
Yeah, yeah, MCQs. If you can do MCQs, structures are easy for you, right? You already understood.
Yes, sir.
In topic one, you already understood. If you are done with the MCQ part, then structured part you can go fast. because the same thing is coming in structured part by writing. That's it. In MCQ, you have to choose the A, B, C, D, but there you have to write in the spaces, right?
Yes, sir.
But ideas are same thing, same concepts. Okay, are you done? It is important to understand
So
this
I'm
part.
liking the last para, sir.
Yeah, right. Actually, these things with the teacher's presence you have to write. Otherwise, some of the things will feel.
Sir, I'm done with para 3.
Yeah. So if you are not having the explanation, then some of the things you might not understand only from writing, isn't it?
Yes, sir.
So here I gave examples of instrument like stopwatch with 0.2 second reading. The uncertainty I mentioned plus minus 0.1 second. So this stopwatch is having the minimum reading. Like you have the scale, right? So in your scale,
Yes, sir.
you can measure minimum 1 millimeter accurately. That is 0.1 centimeter, isn't it?
Yes,
So
sir.
the uncertainty in your ruler, like you are getting your reading, for example, in your with your ruler, you are getting the reading 2.3 centimeter. Okay, for any of the lens you are getting
Yes, sir.
or anything you are measuring, you are getting 2.3 centimeter. So that is your typical reading. Okay, 2.3
Yes, sir.
centimeter. But your uncertainty is plus minus 0.1 centimeter. Is it clear?
Yes, sir.
Are you understanding? And if you are taking only reading once, that is 0.1 centimeter. But if you are taking the readings, for example, three times, how many times?
Three times.
Three times you took the reading. Like once you got 2.3, another time you got 2.3, another time you got 2.2. Okay, then if you take the average, your reading is coming 2.3 in two
Yes, sir.
significant figures, isn't it? But that time your uncertainty will be plus minus 0.05 centimeter.
Yes, sir.
Is it clear to you? So
Yes, sir.
when you are taking the average, then it will be half of the minimum value, the uncertainty. But if you are taking the reading only once, then the uncertainty is the plus minus of that minimum value. Is it clear now?
Yes, sir. Yes, sir.
So look here, for all of them, you see the instrument's accuracy level is still 0.2 second, but our uncertainty we mentioned plus minus 0.1 second. Why? Because here we took the average.
Yes, sir.
Again for thermometer we took the average. Again for ammeter with 0.1 ampere we took the average. That's why the uncertainty is like that. Is it clear now?
Yes, sir.
If we are not taking average only one single value, that time the uncertainty will be plus minus 0.1 ampere. So this one you will take notes. Here when you write all of them, then here you write for the average. For the average. Okay, is
Okay,
it
sir.
clear?
Yes, sir.
Okay, finish it. Are you done, Navid?
No, sir. I'm writing.
Mhm.
Sir, done.
Okay. Did you write about the average? Just below uncertainty, you write for average values, uh, and
Okay, sir.
uh, and also you write the notes for single value only. Uh, for a single value only, it will be this one. Huh? The accuracy level will
Okay,
be
sir.
this one. Uncertainty will be this one,
Yes, sir.
for a single reading only. So done,
Yes, sir.
Now there is the more complicated things, uncertainty types. We have uh, absolute uncertainty, and we have relative. We say it relative uncertainty or fractional uncertainty. Also, we convert it to percentage uncertainty. So, absolute uncertainty means the one already we got here. You see, if the typical value is 16.2, then your uncertainty is 0.1 second. Then this is your actual uncertainty, 0.1. Okay,
Yes, sir.
0.1 is your actual uncertainty. So 16.2 plus minus 0.1. This 0.1 is your actual uncertainty or absolute uncertainty. Is it
Yes,
clear?
sir.
And if you are taking the fraction of 0.5, we gave you one example, like you are getting here 0.1 and 16.2. So if you are taking the ratio of 0.1 and 16.2, that will become your fractional uncertainty, okay, or relative uncertainty. And if you are giving percentage, then it will become percentage uncertainty. Is it clear?
Yes, sir. Yes, sir.
Okay, so you write it please. Uncertainty types, two types. With example given, you write.
Sir, uncertainty calculations. Should I write that?
Uncertainty calculations.
Sir, should I write that?
Wait. Let me check. So uncertainty calculations we do in next class,
Okay, sir.
because it's a huge thing, and if you are done with this thing, then your topic is over,
Okay,
and
sir.
you can go through the worksheet directly after that. So in our next class, we will do uncertainty calculations, and also we will do the worksheet. If you want,
Okay, sir.
then I can upload the worksheet today, and you can have a try with the other things except uncertainty calculations. Should I upload it? Will you try, sir?
Sir, sir, I cannot do it today, but I can try tomorrow, sir.
No, you will try tomorrow because we have class day after tomorrow. So
Yes, sir.
today is very late night. It's not even possible today. You have to go to bed, right?
Yes,
So
sir.
you try tomorrow in your convenience, and day after tomorrow morning you can also try. We have 2 days, right? We
Yes,
have
sir.
class at 9:30, so you are having plenty of time. So should I upload it now?
Okay, sir.
Okay. Okay. Thank you, huh?
Okay, sir. Okay, sir.
Okay.
Assalamu alaikum.
Alaikum salam.